said, by now, you should be able to understand the category of the importance or the importance category of a specific structure. And from that, you're able to find the value of importance factor I sub S. Then based on or depending on the location of the structure, the geographic location, you should be able to find the value of S sub S and S sub R in kBA. Then depending on the size of your structure, the size of your roof, then you should be able to find C sub B, which is in most cases for small structures less than 70 meter is equal to 0.8. C sub W is equal to 1, as I kind of convinced you. And then now probably we have 2 more to go. So C sub S and C sub A. So let's see. So C sub S is a slope factor, slope effect. So guys, please take your time, look at the picture on my screen. You will see on the top there is a Talisman. You know, I think it's kind of it's a leisure center in the southeast of Calgary. I think along McLeod Trail. You know, to the bottom there are some houses with a very high slope roof. And then probably 2 other pictures of other building or other houses. One here has awning. So this part here is an awning, and this part here is a metal roof. So you can see here, those are variety of roofs. And you can see there are 2 factors mainly here. One is the slope, and the other factor is the material of the roof. For the material, sometimes we cover our roof with asphalt shingles or wood shingles, which is kind of a rough material. And sometimes whether we have metal roofing, not very common, but it exists, something called metal roofing, and then here awning. And then here also we have kind of a heavy sheets, like plastic sheet. So the thing, guys, is the material is different. Those are very slippery, like on picture number 1 and the one in the middle to the right. The 3 of them, they are slippery because it's kind of really the surface is not rough. However, the one on the bottom left corner, it's made out of shingles, and those are rough. And hopefully, guys, from this picture, you kind of feel what are the factors to find my slope effect or my slope factors. Let's see, I'll give you more details. So if you just go to the next slide. So this is how the code or what the code says about slope factor. Remember, before I go into the details, that the slope factor is unitless. It means it is a number, it has no units. To do that, so we have to read 3 statements, statement number 5, number 6, and number 7 from the code. Number 5, start again with the word that we don't like, because simply it says except. So there is an exception, except as provided in statement 6 and 7. So we will have to read 6 and 7 first, and then we go back, read number 5. So let's go ahead and read number 6. Number 6, the slope factor C sub S for unobstructed slippery roofs. So the key here is slippery roof. Unobstructed, I'll tell you more details in few minutes, but for now, think about slippery roofs. So it means a roof that the material is not rough. It allows for more snow to fall off the roof. Where snow and ice snow and ice can slide completely off the roof. Roof shall be, so the CS shall be 1 where the roof slope is alpha is equal or less than 50 degrees. Okay. Now on my next slide, I have more demonstration of the alpha. Where is the alpha? What is the alpha? It is the roof slope. It's an angle. So if this angle is less or equal than 15 degrees, and remember this applies on slippery roofs, like awning or maybe the one that like the Talisman, okay? So those are slippery, unobstructed. So if the angle is less than or equal 15 degrees, it means CS is equal to 1. It means it means no reduction. It means all the snow will stay, nothing will go. Now you can see as we increase the angle of the roof, you can think about it. You will see there's some potential or probability that the snow can simply leave the roof and go to the ground, and so we get less load on the roof. So guys, on item number B here, if the angle is somewhere between 15 degrees and 60 degrees, between 15 and 60 degrees. So what happened is you need to use this equation here, 60 minus alpha divided by 45. For example, let's go to alpha equal to 45. So if alpha is equal to 45, so 60 minus 45, that is 15. You divide 15 divided by 45, you get 1/3. 1/3. It means your slope factor is 0.3. It means you're lost already 67% of your load. They leave the roof and they go somewhere else on the ground. Okay. If alpha exceeds 60 degrees, so if you have a a roof that has very high pitch angle, high slope angle, then in this case more than 60 degrees, it means 0. It means your CS equal to 0. And guys, if you look at CS equal to 0, if I go back to the previous slide, I want you guys to think about this equation. If CS equal to 0, guess what happens? So this number is 0. It means hold this term is equal to 0. So you're left with very little, which is SR multiplied by your I sub S. Okay, so very little, which is only the moisture on your roof. Okay. Now, what happened is if my roof is not really slippery, first of all, let's read number 7. And number 7, it says, unless otherwise stated in this subsection, the CS factor shall be 1 when used in conjunction with accumulation factor for increased snow. I know that this is our next discussion. So in the next slide, I'm going to talk about accumulation factor C sub A. So my point here is, if your C sub A, there is a accumulation factor more than 1. So in this case, we still leave the slope factor as 1. Anyway, I'll go back to this one when I show you the meaning of accumulation factor. Now, since we finished reading 6 and 7, let's go back to number 5, which when you look at number 5, it is kind of a copy and paste from number 6. However, we changed the equation a little bit. So in number 5, it says, it means if you have a rough surface, which is not really slippery, in this case, you have to see, depending on the angle of the roof, then it could be in either A or B or C. If your angle is more than 70 degrees, more than 70, so that's really very, very high pitch angle. In Calgary here, probably I've seen only one structure. It's a church along the McLeod Trail in the north, where the angle is so high. So this is very uncommon. But anyway, for angles exceed 70 degrees, then your C sub S equal to 0. How about if it's in between 30 and 70? You have one equation. For example, let's do an example. What if my angle is equal to a 40? Okay, let's say my angle is equal to 40. So 70 minus 40. So now is equal to 30. 30 divided by 40. So this will give you 75%. So if the angle, if your material is rough, like asphalt shingles, and the angle is 40 degrees, then in this case, the slope factor is equal to 75%. It means 25% of the load will go away. If your roof is rough, again, asphalt shingles or maybe wood shingles, this is rough. And in this case, and the angle is less than 30, it means we leave the SCS is equal to 1. It means no reduction due to the slope. No reduction due to the slope. Okay. Now I know a little bit dry, so let's try to make it a little bit easier. So let's go to the next slide. I try to give you kind of a worked example by number to see how this will work in action. So here I have a house. So let's say this is a house. And what you see here is a cross section of the house. And the cross section of the house, it shows a slope of 12 to 5. Maybe on my screen right now, you don't see it very well, but for sure, when you print this one, you will see the slope is over there. And this is 12 horizontal to 5 vertical. Okay. And I write it here. So I give you two scenarios. What if my roof material is asphalt shingles? So that's case number 1. And if the roof slope is 5 to 12, remember, slope is not an angle. So we have to convert. We have to find the angle. So guys, what's the angle? Simply, it's this angle here between the roof and the horizontal. And it's not very difficult. If you know about math, you will know. All you have to do is get the tan or the inverse tan of 5 over 12. If you want to do it right now, please do. So the tan minus 1 of 5 over 12, this will give you 22.6 degrees. 22.6 degrees. And this is less than 30 degrees. Because simply according to this statement here, the limits are 30 and 70. Less than 70, sorry, less than 30, it means 1. And that's why I'm comparing my number to the 30. So 22.6 is less than 30. It means C sub S is equal to 1. It means no reduction for the snow based on or due to slope. And this according to statement number 5. How about if I change my material and I change my material of the roof to metal roofing, and again, see, everything is the same. So I still have the slope is 5 to 12, and then the angle is 22.6 degrees. And remember, if you go back to statement number 6, the limit is not 30. If you have a slippery roof, the limit is 15. And because the number is more than 15 degrees, it means we should reduce the snow a little bit. How? If you go back to this equation here, we need to use equation on item B here. So 60 minus 22.6, and then finally divide by 45, and this will give you your factor. Let's see. So here we go. So 60. Guys, there's a typo. My apology. I'll correct this one. I will re-upload. So this should read minus because the equation is minus. However, this number is right. So this number is right, but this sign here is not really right. It's a typo. So this should read minus. I'm going to take note with this one to correct it. So this is page 13, and then negative. Okay, so 60 minus 22.6 divided by 45. This will give you 0.83. It means my slope factor is 0.83. It means I'm losing 17% of the snow due to the slope of the roof. And this according to statement number 6. Okay. Now, let's go to next. So guys, the next one is something called accumulation factor. Accumulation factor. An accumulation factor is from the name. Sometimes, somewhere on the roof, your roof will not be uniform. When I say uniform, it means when you look at the roof, you will see it's kind of uniform. There is no where there's accumulation. However, if you take some time and look at the 4 picture I provide here, so the bottom, the top left and the top right and the bottom left, those are 3 different pictures. And I'm hoping when you look at those pictures, you will understand and appreciate the meaning of accumulation. So somewhere on the roof, there will be accumulation. And remember, accumulation is very important because simply at these spots and these points, I have more snow. It means I have more load. And if I ignore this accumulation, it means I'm in trouble in terms of my design. I haven't taken all the loads in my design. Okay, now I included here a picture, and I know if you guys still remember from last year, I'm hoping that you guys still remember this picture here. Okay, let's see. Let's make a test. Do you guys remember where this picture is in the city? Speak out, like unmute yourself and say it. I would be super sad if you guys totally forgot about your beloved school. Okay. So this is the entrance. Looks like nobody remember, or maybe nobody wants to remember that. Okay. This is so this is a picture where this is the west entrance. This is the west entrance of Stangrad. Okay. West entrance of Stangrad. I think it's Emma. It's Emma building. Emma building. Probably you had some classes here. So that's the west entrance of Stangrad building, and there is a big canopy. There is a big canopy here, and this big canopy it's hanging back to to the building using 2 cables or 2 rods back to the building. I know I couldn't find any picture that has this canopy and has a snow, but I'm going to convince you, if we take picture on this canopy in winter, you will see accumulation of the snow, same as you see on the top left and the bottom left and the top right. Okay. By the way, so let me introduce this name for you. When we say accumulation, the equivalent name is called drift. So we call snow accumulation or snow drift. Snow drift. And the thing here, guys, is that this will be complicated. So hopefully we'll still be friends after I finish the drift discussion. It's not really easy. You will see there are lots of steps to find your drift. But in general, if you have no reason for the drift, so the load will be on the roof will be uniform. If I go back to this example here, when you look at this house here on the roof, there is no reason. I'm going to tell you what are the reasons for the snow accumulation or the drift. But when we go through this, you will see here on that roof, there is no reason. And when I say no reason, it means the snow will be uniform. So it means the thickness of the snow will be uniform across your building or across your roof. Now, I think it's time to go and tell you the details of that. Like I label here as snow accumulation reasons. So the code here is giving you some reasons, okay? So those, what you see here on my slide, are the reason of accumulation of snow. There are many of them. You can see A, B, C, D, E, F. In my class, I will cover only 2 of them. Only 2, which is A and B. A and B. Okay? Not I'm lazy, but the thing is, those are the most common ones. The most common type of snow accumulation is due to A or B. So what happened here, guys, is A. It says increase non-uniform snow loads due to drift onto a roof that is at a lower level than the other part of the same building. Okay, and please don't continue, because again, don't focus so much within 5 meters, because this is it will be in detail soon. However, really what I want to say here right now is, if your roof has different level, like for example, look up my image on the screen, like a higher roof and lower roof, okay? Or if I go back to stand grab building, guys, when you look at stand grab building, I know this is not a roof, but you can see this is a place where you can collect snow, but you have here on top, we have a roof, and both of them, they are not at the same elevation. This causes accumulation or drift. Multi-level roof. Okay. Next is on item number B. It says here increased non-uniform snow load on areas adjacent to roof projections. And I know maybe roof projections is not really a very common name, so I'll explain in details what does it mean. It says here such as penthouse, large chimneys, and equipment. Something also the parapets. So around on the roof, typically we build the roofs with parapets. So the parapet, the function is to simply hide the mechanical units on the back of the parapet. But those are the 2 reasons I'm going to teach you in my class. One more time. Number 1 is if you have a multi-level roof, a roof which has not all the roof has the same elevation, so multi-level, which the canopy is another example of multi-level. And next is roof projection. Anything that projects from the roof up, like chimneys, like penthouses, or maybe mechanical unit. If you guys remember, on any of our building, if you look at stand anywhere at SAIT and look at the roof, you will see every roof will have mechanical unit, and those mechanical units as for air makeup unit and stuff like that. Okay, so those will be covered in my class. Let's move on and see what's next. So guys, I want to be probably before I hit the point, so now you know an idea about the equation of the snow. So let's revisit the equation one more time. And this slide here, I would say, is kind of a summary, very nice summary from my perspective. So one more time, the snow equation is On the left side here is my target. I am after finding the snow on the roof, represented by S, and this number will be NKBA. On the right here, I have to find all those parameters, because if I find all those parameters, I can find the one on my roof. Okay, importance factor. It represents the importance of the building under design from an engineer perspective. Then SS and SR, those are function of the location. When it comes to those 4 factors, here is the summary. CB is always less than 1, cannot be more than 1. You cannot get more snow on the roof more than the ground. You cannot. Okay? The maximum is what you get on the ground, but on the roof you get less, and that's why CB is always less than 1 or equal. In most cases, your CB is equal to 80% for a small roof. What's the meaning of small roof? LC is less or equal than 70 meters. C sub W, it is the wind exposure. I think I convince you. In general, it can be equal to 1 or less, but in general, in our classes, we use it for 1 for safe design. Now, the third one is the slope factor, equal or less than 1. If you have a slippery, then we can increase, with the increase of the slope, we can simply reduce the snow by a factor less than 1, depending on whether your roof is non-slippery roof or slippery roof. So you have to look at the material before you think about the angle of the roof. Guys, here we go, the last, which we haven't covered so far, but I want to give you a heads up. The heads up is, this is the only factor, the only one. You can see all of them. They can be maximum 1 or less than 1 if some conditions are met. However, this is the only one among all those factors that's minimum 1 or can exceed 1. So when this number is equal to 1, where there is no reason for accumulation. There is no reason for accumulation, then this number is equal to 1. However, in some area, and I already mentioned 2 of them, which is multi-level and close to roof projection, this CA will grow more than 1. It will be 1.5, will be 2, will be 3, will be 5. We will get into lots of details shortly. But for now, I want you guys to look at this slide here, kind of gives you the big picture of our calculations. 3 factors, less or equal number 1. Only 1 factor, which is accumulation factor, it leads to a number more than 1. Minimum 1 if there is no reason. If there is 1 reason, then we get snow more or CA more than 1. Okay, let's go to the business. Okay, so guys, before simply I give you the CA, let's do it simple. Let's say I want to estimate the snow above a house, and I'm taking this exactly the same house I've done before, which is the slope is 5 to 1. In Calgary, it is house. So let's see if we can or are able to find the snow load on top of every house of our houses in Calgary here. Okay, you will see it's not very difficult, although discussion looks difficult, but you will see it's not very difficult. Number 1, since the building or the house is in Calgary, actually I should correct something. I'm sorry, I should correct something. So this should read on a house. I know it looks like a house because there is a garage, there is a kitchen, there is a master bedroom, but I should correct this one to a house. Okay. So this is page number 17. Okay, so this house is located in Calgary, and because it's Calgary, you can pick from the table the climatic information, which is S sub S and S sub R. As you guys remember, I said I have done hundreds of buildings and structures in Calgary. So those numbers are here, 1.1 kBA and 0.1 kBA. Number 2, because it's a house, so a normal importance, which leads to I sub S equal to 1. Okay? And then I wrote here basic snow factor equal to 0.8. And I ask why. Can anybody guess why? Anybody can tell me why? Show your hands if you know why I should use here 0.8, given that this is a house. Okay, let's see, Brody. Brody, go ahead.
Length is less than 70 meters.
Okay, you know what if we have a house where the L sub C is equal to 70 meter? Do we still call it a house?
I mean, you could. It'd be a mansion.
I mentioned exactly. So I'm going to ask you, since you're discussing this with me now, guys, bro, do you think like the normal house, like the average house in Calgary, what are the dimensions, or what's the dimensions of the house?
I'd
You
say
know roughly?
it's at most 50 feet, so probably like 21 meters long or so, if that.
You know what? Like I can tell you something. You're not really far. I can kind of agree. But you know, most of the houses here, the plan area will be around 1,000 square feet. 1,000 square feet, and 1,000 square feet. It's 100 square meter, and 100 square meter is 10 by 10. 10 by 10, and if it's 10 by 10, then the L sub C is 10. So I can say comfortably, I can say 70 meter L sub C for a house. As you said, it will be a palace. It's not going to be a house. And that's why I said C sub B is equal to 0.8. So that's C sub B. Wind exposure. We already agree that it's kind of a safe design to never assume that there will be or will never be plants around the house or trees. And simply we use C sub W equal to 1. Also today, just a few minutes ago, I said slope factor is equal to 1. Okay, and I think the assumption here is the asphalt, the material of the roof is asphalt shingles, which will lead to CS is equal to 1. If you cannot remember, again, go to 2 slides back and you will see where I did the CS for the same cross section. So C sub S equal to 1. Now, the last one, the accumulation factor is equal to 1, C sub A. Why the accumulation factor is equal to 1? Because simply on the section you see, number 1, there is no roof projection, and there is no multi-level, okay? So that's why there is no reason for accumulation, and whenever there is no reason, the snow accumulation factor will be 1. It means the snow will be uniform. Okay, now it's time to put all those into the snow equation. So I kind of put it in a box below. So S, which remember, S is my target. I want to find the snow intensity on my roof equal importance factor 1 multiplied by the S sub S 1.1 in Calgary multiplied by a series of factors CB 0.8, C sub W equal to 1, C sub S 1, and then finally C sub A is equal to 1, and then finally you add a little bit for the rain or the moisture, and then if you do the calculations you will see it is 0.98 kBA. So roughly or approximately this is 1 kBA. So guys, we know, let's confirm this one. In every of our houses, every house of the houses that we live in, it is designed for a snow of equal to 1 kBA. And remember, it's in Calgary. If we take the same house or we build the same house in somewhere else, let's say in Banff, you will see the number will be different, even though you think all the parameters are the same. For example, like the basic snow, because the size, the wind will always be 1. The house has the same slope, so still the CS is equal to 1. There is no parapet or there is no mechanical unit, so it means C is equal to 1. However, once we change the place or the location of the house and we take it to Edmonton, then in this case, that we need to ask for more load. And that's why moving houses, let's say you have a house here, you build a house in Calgary, and sometimes we do, I'm not sure how many of you guys have seen house move. We take the whole house, we move it somewhere else, okay? If you move your house from Calgary to Calgary, okay, I think your design will be still valid, your house still be okay. However, I guess if you move a house from Calgary to some other town or city close to Calgary, the engineer will have to go back and make sure that the house is strong enough, because simply the snow load will change. Does it make sense? Does it make sense now? Does it? Okay, guys, look at this. So the next slide is talking about the stuff which I guess both of us, we don't like, which is simply the difficult part. The difficult part is we will talk in next class about accumulation, like snow accumulation, and you will see lots of mathematical equations and lots of more details. And that's why I want to probably do that on Monday. Okay? So we'll stop here. You have the material. I kind of did my best to come up with a kind of a good slides. It takes a lot of time, but again, hopefully this will give you a good material for study. Okay, so I'm gonna stop now. I'm gonna ask for questions. Questions. Okay, so let's say hi for somebody. How about if we say get some feedback? Let's ask. Somebody today is kind of quiet. Where is Hamid?
I'm here. I'm just following along.
Okay, so you're okay?
Yeah.
Okay, thank you. I haven't heard Kyla for some time. Kyla, are you with us today? Kyla? How about Daniel? Daniel, are you with us? Ben, Ben, are you with us?
Yeah.
Are you
I'm
following?
Yeah.
Are you following?
Yeah.
Do you have any questions?
No.
Okay, thank you. Nicholas. Nick.
Hello?
Hey, Nick, how are you doing?
Yeah.
Are you following?
I have a question for you.
Oh, sure. Do I have to call your name to ask questions?
No, I was just following along.
Okay.
The SR, would that be considered like a slush type material?
You know what? To be honest, like I would say as an engineer, I would say yes, true. But again, that's per the code. So whatever, those equations, they are empirical equations. They are based on testing and experiment. So as an engineer, I know a little bit about them. Okay, so the nature of them, I would say it's kind of the moist component of your snow. More than that, I don't know. But I would agree to you. Okay?
Okay.
Thank you, sir. How about Rizaline? Rizaline Dulmondo.
Yeah, I'm following.
So you're okay?
Yeah.
Okay. Ryan, how are you doing?
I'm doing good, yeah.
Okay, thank you, sir. How about, so I think I heard Siham today. Do we have Siham?
Yes, I'm here.
Are you following Siham?
Yeah, no questions.
Okay, thank you. Nick,
Thank you.
Nico.
Hey, what's up?
I'm just checking on you, like, if you're doing okay,
Yeah, I'm good.
if you're following.
Yeah, I'm good.
Okay, thank you, sir. Last but not least, Sebastian. Sebastian, are you following? Okay, looks like Sebastian is not here today. Anyway, guys, we're done for today. I'm gonna see you guys one more time tomorrow, but as a surveying teacher, no concrete, no snowdrift. Okay? Have a wonderful day.
Thanks, Tahir.
Oh, you're welcome. Thank you, sir.